All right, we're going to factor this as well. And once again, the first thing you should always do when it's asking you to factor polynomials like this is see if there's any greatest common factors to pull out. And since the coefficient of x to the power of 2 is just a phantom 1, I'm not worried about pulling out numbers. And then not all three terms have x's either, so there's no greatest common factor that I can pull out of these. So what I'm going to be doing is looking to factor this out into two separate binomials with, we got the x's as our first term in both binomials, okay? And this is going back to that rule where we say, look, we got the constant there of positive 20. I want to look at all the factored pairs of 20 and see if anything adds up to 9, right? So I'd say, you could say 1 and 20, that would work. Oh, well, 1 plus 20 is 21. It's not, it needs to be negative 9 though, right? It needs to be this negative 9 coefficient of x. But 1 plus 20 is 21, so let's try 2. 2 and 10 added together is 12, so that doesn't work. 4 and 5 add up to 9, but this is a negative 9 coefficient of x, so that's not going to work either. Well, that's not all our options, because we are multiplying these together, these factors, which means if I made each of these negatives, then it will still result in a product of positive 20, but it should add up to be negative 9, one of these, right? So for example, negative 1 plus negative 20 is negative 21. It's still not negative 9. Negative 2 plus negative 10, still not negative 9. It's negative 12. But yep, we see it right there with the negative 4 plus negative 5 is negative 9. So that matches. And these two factors of 20, I just plug them in directly into these two binomials. Okay, so I put the 4 in the first one and the negative 5 in the second one, but it doesn't matter if you had those switched to be x minus 5 in the first parentheses and x minus 4 in the second parentheses, but that's our answer right there.